Hi everybody, welcome to another video in Calculus 1, section 3.1, introducing the derivative. So we'll revisit the problem of rate of change and tangent lines. So the average rate of change is the slope of the secant line. So we have 2 points. We can write that A and f of A is 1 point, and then B and f of B is the other point. So the slope of the secant line is given by this. Now instead of write A and B, we will write A and A plus H. So in that case, we will let H go to 0, so the distance between them gets smaller and smaller. Essentially, we find the limit, and the limit of the limit of the slope of the secant line is the slope of the tangent line. So we can see here there are 2 points, and there's the secant line. We take 1 point fixed, and the other point get closer and closer to it, so the line essentially becomes the tangent line, and the slope of the tangent line therefore is given by that. And once we have the slope of the tangent line, we can put together in the equation of the tangent line, where A and f of A is the point where the tangent happens. Right, so let's look at the first example. Find the slope of the tangent line of the graph at the point 1 and 80. So the point 1 and 80, A is equal to 1, and f of 1 is equal to 80. Right, but we don't even need that. I first write out the formula. F of H plus H minus f of A over H. Right, now A is 1. So if f A is 1, so we have that. Now the function is negative 16 x squared plus 96x. So I'm going to put 1 plus h into x squared, and then I put 1 into x, and then x here. Right, first we have negative 16. Instead of x squared, that will be 1 plus h. And plus 96, and instead of x, put 1 plus h, and then minus f of 1. F of 1 is 80. Of course, if we want to confirm it, A is equal to 1, so 1 store onto x, and we have negative 16x squared plus 96x. That's 80, so that's correct. Now we just need to multiply this out and then simplify. Right. 1 plus h squared. 1 plus h squared is 1 plus a times 1 plus h. Multiplied out 1 times h, a times 1, and h squared. So that gives us 1 plus 2h plus h squared. So So here we have negative 16, 1 plus 2h plus h squared minus 96, 1 plus h minus 80 divided by h. Just multiply them out, simplify. So negative 16, negative 32h, and negative 16h squared minus 96 minus 96h minus 80 all over h. Right, let's look at the numbers. Negative 90, oh sorry, this is a plus, right? Sorry, that was a plus, so this will be a plus. Right, now 96 minus 16 is 80 minus 80, so 96 will cancel with negative 80 and negative 16 and all add up to 0. I mean those add up to 0. And 32 and 96, that's negative 32 and 96, so that is 64. So that is 64h. By those two, and minus 16h squared. Factor out an h. And cancel out an h. Have 64 minus 16h, and then substitute 0 in for h. We have 64 so just 64. So the slope of the tangent line is 64. Once we have the slope of the tangent line, we can find the equation of the tangent line. By minus f of a is 1 equal to the slope of the tangent line x minus a, which is 1. Yeah, so a is 1, and so we have y minus f of 1 is 80. The slope is 64, and x minus 1. Multiply it out. 64x minus 64 and minus 80 on the other side. So y equal to 64x plus 16. 80 minus 64, that's 16. Right, so that's what we have. Right, so if we want to check, we will graph first negative 16x squared plus 96x, and the other equation is 64x plus 16. Of course, if we graph like that, we won't be able to see it, even though the tangent line is when x equal to 1, but the y value is 80, so we have to make the graph big enough. So the x values could be just from 0 to 10 if we want to, because the tangent occur at x equal to 1. So we can say 5. Good enough. The y values, because the point intersection, I mean the point of the tangency is at 80, So we will have to choose something big enough. So let's say from negative 10 to 100, for example. And we have 10 for each. Right. Now we have that equation. And then the tangent line. Right. Might not need to increase a little bit. How about 180? Right. So that is the graph. And that's the tangent line. So that looks good. By the way, once we're done with this, I'll hit zoom number 6. Get back to the stand-up window. Right. Look at another example. I'll find the equation with tangent line of the graph at the point x equal to 1. So first, the slope of the tangent line. Just this real quick. Slope of the tangent line is equal to the limit of h go to 0, f of a plus h minus f of a over h. Now a is 1. Right. And then we're going to put 1 plus h into the function instead of x. So we have something cubed. Instead of x, this is 1 plus h. And then plus 4 instead of x is 1 plus h minus f of 1. So what is the values of the function when x equal to 1? So 1 is turned to x, and then x cubed plus 4x. So that is 5. Yeah, so let's try. F of 1 is equal to 5 over h. Right. Now we just multiply it out, simplify everything, and find the limit. Right. So 1 plus h cubed. 1 plus h cubed is 1 plus h. 1 plus h times 1 plus h. Where two of them multiply together, that's what we have. So that's why I choose 1 here. Yeah, this together is 1 plus 2h plus h squared. Let's multiply this out. 1 times all of that is 1 plus 2h plus h squared. And then h times all of that. H times 1 is h. H times 2h. H times h squared. And when we add them, 1 plus 3h, 3h squared, h cubed. Right. So we have 1 plus 3h plus 3h squared plus h cubed plus 4 plus 4h minus 5. Now there's a common thing when we do this. The numbers, we cancel each other out. So negative 5 plus 4 plus 1. Of course, they add up to 0, right? So those all the numbers gone. Next, the h, we have 3h, 4, and that is 7h. Three and 4, and 3h squared and h cubed over h. We can factor out the h. And we have 7 plus 3h factor out h, 3h plus h squared 1 over h. Cancel out. So we have 7 plus 3h plus h squared. H go to 0, so we end up with limit. When h go to 0, I just substitute 0 in for h. 7 plus 3 times 0 plus 0 squared is 7. So that is the slope of the tangent line, 7. Next, we find the equation of the tangent line. Y minus f of a equal to slope of the tangent line, x minus a. So y minus f of a is 1. The slope of the tangent line is 7. And then x minus a is 1. F of 1 we did calculate earlier, which is 5. Multiply it out. Y minus 5 equal to 7x minus 7 plus 5 on both sides. Y equal to 7x negative 7 plus 5 negative 2. That is the equation of tangent line. Of course, if we want to, we can verify with the graph. X cubed plus 4x. Sometimes type that is a lot faster than type x cubed. 7x minus 2. Right, so you see when x equal to 1, so we have the cubic function and then the tangent line. So that look correct then. Right, now it's good. It's not that bad when we do to find the tangent slope of the tangent line this way. So it's not that bad. Right, now the problem is that's good when x equal to 1. Now I will change. What happened when x equal to 2? We have to do this process again. And how about we change different values to it? And the point here is, why don't we have to put a particular number here? Why don't we just keep x? In that case, we have the slope of the tangent line with as a function with x in it. So if you have a values, we just substitute in at the end. So my point is, we don't need to do this for every time for every particular number. We don't have to do for x equal to 1 every single time. And then when we go to 2, we have to do this process all over again. Why don't we just keep x in it? And then at the end, if we want to, we can let x equal to any number we want. And that's exactly what we do. In that case, that is defined to be a derivative, which is the most important concept of calculus 1. Right, so as the point moves along the curve, the tangent line moves and the slope changes. If we want the slope as a function of x, if we want to write the slope as a function of x, we define the derivative as this. So this is the definition of the derivative, just the slope of the tangent line. When we keep the x is a variable, we don't put any particular number in it, we just keep x. And so the derivative is a function of x. And if the function is differentiable at every point in the interval, we say the function is differentiable on the interval. So it's no big deal here. So the difference here is instead of put any number in for x, any number for a, we're just going to keep x, and then just from that, and then at the end, if we want to, we can let x equal to any number we want to, right? So that is definition of derivative. So let's say we have that same function we have earlier. Question here is find the derivative. So derivative, by the way, the notation, the simplest notation is the prime sign or the apostrophe, and the way we say this is f prime of x. So that f prime of x, by definition, limit as h go to 0, f of x plus h minus f of x divided by h. Right? So yeah, we do that in general for x because derivative is the function of the same variable. Right. So the function is f of x equal to negative 16x squared plus 96x. So first, I'm going to put x plus h into x. Plus 96. Put x plus h in for x. So that's the first part of it. And then subtract f of x, which is the same thing, so I don't do anything, just rewrite the function. Right. I just like the last one, multiply it out and simplify. Right. Right, so I have x plus h squared is x plus h times x plus h. Multiply it out, x squared plus hx plus another hx plus h squared. So x squared, that gives us 2hx plus h squared. I will substitute that in here. Negative 16 x squared plus 2hx plus h squared plus 96x plus 96h, and then subtract the function minus negative, that plus 16x squared minus plus minus negative 96x over 8. Right, multiply it out. So negative 16 x squared negative 32 hx negative 16 h squared 96x 96h 16x squared minus 96x 1 over h. Right, we have negative 16x squared cancel out. 96x cancel with 96x. And what's left is those three terms. Right. Now since all of them have h on the top, I will factor it out. And to cancel the h at the bottom. Right, and then the h cancel out. We just have negative 32x minus 16h plus 96. Put in 0. 0 in for h. And we have negative 32x plus 96. So in general, if we just keep x and we don't substitute any particular values in, that's what we have. Now let's go back to the previous, the first problem we did. When x equal to 1, it is equal to 64. And if we put 1 in here for x, negative 32 plus 96, indeed is 64. So that's correct. Right. Now, next, I'll find the slope of the tangent line at x equal to 1. We already did this on the first problem, so we're not going to do this again. We just said find the slope at x equal to 3. Only because x equal to 1, we only did it. Now, the nice thing about this is we don't have to do all of this again. We already have the function for the slope, the function for the slope which we call the derivative. So if we want at x equal to 3, all we do is just put in the tangent at x equal to 3 is the derivative when x equal to 3. So we have 3, and this is the derivative, which is the slope or the function of the slope, pretty much. Put 3 in for x. And we have 96 minus 96 plus 96, that is 0. And finally the equation y minus f of a equal to the slope of the tangent line, which is 0 in this case, x minus a. Right, a is 3 and the slope is 0. Right, 0 times anything on the right hand side, so that is 0 on the right hand side. F of 3, I put 3 in for x. Minus 16x squared plus 96x. So when x equal to 3, the function is 144. Move 144 over, we have y equal to 144. Right. So we have y equal to 144 instead of the function negative 16x squared plus 96x. Right. Of course, if we hit the graph like this, we don't see it. So we have to change the windows. Let's say if we go from 0 to 6 or 5, doesn't matter. But y values though, negative 10 is good, but have to go past 144. Let's see 1. 80 like we did earlier. Right? So that is the function, and the line in it is the tangent line. And it's a horizontal line. Right, so let's go back to the previous one real quick. So now the tangent line, the slope is positive if it go up, and it's negative if it go down, and when the slope equal to 0, it is horizontal. So in this case, because the slope is equal to 0, we have the horizontal line, and there will be more on that in the next few sections, but for now that's what we have. Right, before we go any further, there are a lot of different notation for derivative. By the way, when we're done, just hit zoom number 6. That's what I usually do, so it's ready for the next problem very much. For the standard Windows, zoom number 6. Right, before we go any further, there's some notation of derivative. There's only some notation of derivative. There are a few more of this. So for the function y equal to f of x, whenever possible, the simplest way I do is just put the prime sign to it. This for the derivative, it's the prime sign. Or if we want to be more precise, when we write y prime, we don't know which is the variable. So if we want to be more precise, we can say dy over dx. And why do we write like that? Remember, back in the most fundamental of the slope, y2 minus y1 over x2 minus x1. So this is the most fundamental slope of the secant line go through the 2 points. So here we can say the difference of the y over the difference of x, and that delta we change to d. Of course, we will study this also in future section. But for now, we can write the notation is d over dx for the derivative. Could be y, could be f. And then we can, we rarely use this notation. And if we want to evaluate at the point, there's a different way. We can write like this, or derivative evaluate at x equal to a, or derivative evaluate at x equal to a. So that's a lot of different notation for derivative. But like I said, we prefer to use the prime sign. I prefer to use the prime sign whenever possible. That's the most compact notation of derivative. Sometimes we want to be clear about what is the variable. In that case, we write dy over dx. Right. So we will spend the whole chapter 3, the later part of chapter 3, to find the derivative, how to find derivative. But for now, we use the definition to find the derivative. Right. So the definition is limit h equal to 0 f of x plus h minus f of x over h. And also, if this is a lecture class and you have to take the test in class, one of my questions will be write down the definition of derivative, which is that. Right. Now the function is the square root. So first we have the square root, the function at x plus h. So I'm going to put x plus h instead of x, and then subtract. The function f of x is just square root of x. All of that over h. Right. Of course, when we're trying to find the limit, put in 0, put in the limit and see what happens. And then if it is indeterminate, and then we do some other things. But remember, when we have the square root like this, the way we do that is multiply by the conjugate. So I will multiply by the conjugate. Right, the top is square root of x plus h minus square root of x. The conjugate is the same thing, but with opposite side in the middle. So multiply that top and bottom. Right. Before we multiply it out, there's one thing I want to note from the last previous problem. You will find out that when we find the derivative, by definition, there's always an h at the bottom, right? And h go to 0. So the denominator go to 0. So that's never good. So somehow we have to cancel the h at the bottom. And so that will involve 2 steps. So the first, like I said, we have to get rid of the h at the bottom, because h go to 0. That's never good. So the first step here, we will see the first note we see here is, if it is done correctly, the h at the top, I mean everything without an h, cancel. The term with an h will remain. So terms without x are cancelled. Terms without x are simplified. That's the first step. Because the term without x are simplified, we can factor out an h, right? So since all of them have to have an h in it, sorry, term without an h, term without an h are simplified. So all the term with an h, without an h simplify, everything else had to have an h in it, so we can factor out and cancel the h at the bottom. So the next step that we usually see is factor h out to simplify the h at denominator. Usually when we use, for the simple problem of use definition to find derivative, we have this step. Right, now go back to our problem. Right, now we multiply it out. I'll multiply the top, first square root of x plus h times square root of x plus 8 multiplied by itself is the square. And then that times square root of x. And minus square root of x times square root of x plus h. And minus square root of x times square root of x multiplied by itself is the square. Right, so that multiplies the top. I do not want to multiply the bottom. The reason is I want the h there by itself, because if it works out perfectly, I should be able to cancel that h. So the h should be there. Right, so I just rewrite the denominator, don't do anything. Now, one thing we see that the middle term, 1 opposite, 1 plus 1 minus, so that cancel out. So square cancel, we have x plus h. And then minus square root, square cancel to square root minus x. So the top, that's all we have. And before we say, terms without h are simplified. Indeed, we do have those terms without an h simplified. And after that, we have an h on the top h, we cancel with the h at the bottom. Will be 1. And square root of x plus h plus square root of x. And then we can put 0 in for h. So we have 1 square root of x plus square root of x. And square of x plus square root of x, make that 2. So we have that. Right. So that is our finding derivative using definition. Now we'll do the same thing for this function. Again, the definition of derivative is this. Right. By the way, when we go to section 3.3 and the remainder of chapter 4, we learn a different way of finding the derivative. So we don't have to do this. This takes a lot of work. Yeah, there's some certain rules about finding derivative. So we don't have to do this every time. Right, first the function is 2 over x, 2 over something. So first thing is I'm going to put x plus h into x. And then the other one is f of x, which will be just 2 over x. So we have 2 over x plus h minus 2 over x over h. Right, so how do we simplify this? So to simplify this, we have the complex fraction like this. First, we write h over 1, so we have fraction everywhere. Right. To simplify this, we multiply top and bottom by the least common denominator. We have x and x plus h. Right. So I multiply that to everything, to every term on the top. So 2 over x plus h multiplying x plus h minus 2 over x times x and x plus h over h x plus h at the bottom. Alright, we're multiplying x plus h cancel out, the x and the x cancel out here. So we have 2x. That cancel out, we have 2. X and x cancel, minus 2. X plus h. And then the bottom. Multiply it out. Two x minus 2x minus 2h over h x plus h. Once again, I do not want to multiply the denominator out because the h there, when h go to 0, I prefer to keep the h there to simplify with something. Right. So the step that we see is first every term without h will be simplified. Right? So that's the first thing. Everything without an h, so you see 2x minus 2x. That's good there. So we're left with negative 2h. The denominator still stay the same. So that's the first thing we see. If we do correctly, more likely we see the step where we cancel everything without an h. So the h on the top we cancel with the h at the bottom. So I have negative 2 over x times x plus h. Now h goes to 0. We have negative 2 over x, x plus 0. X plus 0 is still x, x times x is x squared. So that's how we find the derivative using definition. Those are classic examples, so you have to see, have to do something like this. Right. When we go to section 3.3, when we learn some certain rules of derivative, then we don't have to do derivative like this anymore. But for now, when we're trying to find derivative, we can use the definition, and that is how we do it. So that is the focus on this section. Define the derivative and use the definition of derivative to find the derivative. Right. So I stop section 3.1 here. Thank you for watching. See you in another video in Calculus 1.